Greetings. Now we are looking into the second part of algebra functions. This topic I'm going to teach is about linear law. So what it does is it converts non-linear equations in the form of y equals mx plus c. And linearity can be in any form, and just make sure that no variables next to the c, which is the y-intercept. If you look at the form at the top, y equals mx plus c, the m and c are constants, the y and x are variables. And why we do this is because linear form makes it easier to understand relationships, and the interpretation is better. So there are few steps to do linear law, as this is important. Okay, so first of which, you convert a non-linear equation into the form of y equals mx plus c, and then you create fill up the table for new data involving corresponding uppercase x and uppercase y. Just make sure you follow the linear form that you made. Then all you need to do is draw a linear graph of uppercase y against uppercase x. Then find m and c from the graph drawn. Do not find m and c using the original values because we already converted to the linear form. So you find m and c from the graph drawn. That is how you do linear law questions, and this will come out in SPM and A level. You can see it in the picture. I've already shown you how to perform linear law. Next, we're looking into quadratic functions. So quadratic functions is x to the power of 2, which is to say the highest degree in the function is 2. A determines the shape of the graph, B determines horizontal position, and C this determines the y-intercept. And you look on the right, you can see that the graph of a quadratic function is in the form of a parabola. If you want to find x-intercept, which is the root, set fx equals to 0 and then solve for x. As for y-intercept, you get the c from the original expression. To get the vertex form, you need to find two things. First, the equation of axis. Second, the vertex. And to get equation of axis and vertex, you can use the pictures that they find on the right, and I will show you how to get the roots and the vertex form. Now you see the two pictures on the left. These are what you get when you perform completing the square. If you perform completing the square, then you're going to get a quadratic formula, and this formula is generalized for all quadratic functions. And inside the square root in the formula, you get something called the discriminant. So discriminant determines the root types of a quadratic function. For example, if the discriminant is more than 0, you have two real solutions. If it is equal to 0, you only get one real solution, or to say one root. If it is less than 0, then you won't get any real roots, but instead you're gonna get something called complex roots, which involves the number of something called imaginary number. But we will talk about it in the complex functions. Look at the bottom, the vertex form. You see the general form. If you perform completing the square on the original function, eventually you're gonna get the form of a enclosed with bracket x minus h, and then square outside the bracket, and then plus k. This is how you get the vertex form, and it's so much more straightforward just to get the formula itself, and you can like directly get the coordinate of the turning point from there. Now let's look into inequalities. Inequalities, they show the representation of the formula inside a diagram, and this to show how much something is obtained, or how you like fit into the constraints. So if you look at the indicator at the top, you can see that the one that is strictly like without the equal sign together, that you would use a dash line. And from the question, need to look for the keyword more than or less than. Whereas if you look at the one with the equal sign, more than or less than with the equal sign, then you need to draw a solid line. Look for the keywords at most or at least. That is how you interpret a question and draw from the draw the graph according to the constraint. And this will be used in linear programming. As for linear, it takes up the form of ax plus by more than c. The sign will differ. So all you need to do is you let y be the subject. That is how you perform inequalities. And then you just use the expression where x is on one side, draw the line just like how you do in doing the linear form. You need to shape the line according to the inequality that you've obtained. Like example, you see the diagram at the bottom? Yeah, that's right. If the line is solid, then the inequality sign has an equals. Otherwise, dash line is the one without the equals. And you need to realize that to the left and bottom, it is less than, whereas to the top and the right, it is more than. Now, let's look into quadratic inequalities. As opposed to linear inequalities, quadratic inequalities will give you two results. And this one, it has two roots. Look at the diagram on the right. I've already put down the conditions as to how you shape the diagram and get your answer. And if you look on the left, notice how I've already explained what to put when the sign is like more than or less than. The ones with the equals will also follow. Like, okay, you see the one on the left. Okay, so the first one, this whole thing is like a theorem. So the first one, if you need to make sure that all the equation is in the form of ax squared plus bx plus c more than 0. Like, make sure it's a quadratic expression and that the 0 is on one side. Let this to become 0, equal to 0, so that when you solve, you're gonna get conditions that will match the graph on the right. So you perform like something, complete the square or quadratic formula for number 1. You get the x to be less than the first root, but as the second root is the one where everything will be shaded on the right. The second is the opposite. You perform the same as the first one earlier, but the result is x is in between the two roots. That is how you solve linear inequalities. Now, let's take a look at the modulus function. So, modulus gives the absolute number regardless of sign in between the two vertical lines. For example, if you put a positive number or a negative number inside the modulus function, eventually you'll get a positive number, and this positive number is a real number, and the modulus graph is V-shaped. As you can see on the right, it has a sharp vertex point. There are a few rules to this. The first one being that a minus b equals to b minus a with the modulus present. That is because both numbers, the pure numbers, are equal on both sides. Then the first rule is applied. For the second one, this one is a little strange, but with the square present, you are basically turning a negative value into a positive value with square. This is because the squaring has the ability as a negative number that is squared, where the negative number is inside the bracket. Eventually you get a squared number that is positive. These above can be used to solve modulus equations, but for this case we will focus on linear modulus only. Look at this. We are going to look through the modulus equations and inequalities. So with the workings present, for the first case, if you have a modulus function equation that is constant, then you use modulus basic property. For the second, if there's a modulus on both sides, then you square both sides. For the third case, however, is different. If you have a modulus linear equation and a linear equation without the modulus, then this one requires you to use graph. I'll explain why. So if you look at the top left, this is how you do the working. If this were inequality, just make sure you follow the inequality sign. If you look at the second one, we are using we are looking into the second case, which is by squaring both sides. And because it's an inequality, I have shown how you solve this equation. It's a bit long, and you have to you have to use your knowledge on solving linear inequalities to get through this question. For the third case, however, it is very different, as because you're going to use a modulus graph, you need to draw the line to depict the answer clearly on the graph. This is because if you square both sides, eventually you get an indeterminate value, and because because the modulus involves both answers, you don't even know which one to accept or to reject. Eventually, if you look at the diagram that I've drawn, you can see that the dotted line is not included because it's used to indicate the working, how you get the answer. So if you square both sides, you get the wrong answer. For this reason, we use the graph, and this is used to clearly indicate how to solve this kind of equation. So if you look carefully on the right, the working, this is how you solve for number 3. And that is all for my video. I hope to see you in another part of algebra functions, where I'm going to explain about polynomials and partial fractions. Thank you.